if I have the polynomial x squared plus times x minus 3, what's going to be the degree of that polynomial, guys? If I multiply it all out back to its standard form, and I say x squared times x, I get x to the minus, right? So the degree of the polynomial is 3. Yes? If that's odd, remember when it comes to my degrees, if I have f of x is equal to a positive x to an even number, my end behavior is like that, right?
Hey, we cannot hear you.
Uh-oh. You should. I don't have. Oh, I do. Okay, how about now?
Yes, ma'am.
Okay, thank you. All right, so if I have a negative x to an even whatever happening in the center, whatever's happening between my two ends, my end behavior is going to be them facing down, right? And then if it's odd, 1, 3, 5, 9, anything odd with a positive, my end behavior is going to be up and down. Odd with a negative x, flipped over the other way, right? So I'm looking at my degree, and it's a 3, and my x is a positive out here, so I know that my end behavior is going to be like that. Regardless of what happens, here I'm going up and down, over here I'm coming down, right? That's how this graph is going to end. My x-intercepts, I have x squared equals 0, so that gives me a 0, 0. I have x minus 1 equals 0, 3 equals 0, so that gives me a 3, 0 for an x-intercept, right? So I know I'm going right here, and then here. Y-intercept, well, if x-intercept has a 0, 0, then y-intercept is 0, 0, 2, right? What constant would be at the end of that? Just a 0, right? And that constant at the end of the whole polynomial always tells you your y-intercept. So my zeros are the same thing as the x-intercept, but I got to talk about that multiplicity. Remember, if you have an exponent on there that's even, you're touching. But if you have an exponent on there that's odd, you're going to cross. So my zeros are going to be 0 with a multiplicity of 2. So that means that I'm going to touch the x-axis at 2. Then I have 3 right here, and that has a multiplicity of 1. There's a 1 there, and that means that I am going to cross the x-axis, right? Even you touch, odd you cross. So I know here at the 3, I'm crossing the graph. I know here at the 0, I'm going to come back up and touch and go back down, right? What's the degree of my polynomial? What's the highest exponent I got up there? 3. Turning points is going to be the degree minus 1, right? So how many times is this polynomial going to turn back around? It has a degree of 3, so the number of turning points is going to be 2, right? Okay, and that works because my end behavior, I'm going to be coming down, cross, go down, and come back down again. I need to get some accuracy on here. So what am I going to do? I am going to find some points outside of the points that I know. I want something after this 0, 0, and before that 3, and after that 3. I'm going to get in between these points that I already have so I can fill in my graph. So I have 0. That means I'm going to find what is f of negative 1. Because I'm here at 0, I know it's coming down, and I know it's going to continuously come down, but I don't know the slope of that line. I don't know how steep that line is going to be. So if I find my f of negative 1, that's going to give me some direction. How am I going to find f of negative 1, guys? Plug it in, right? Negative 1 squared times negative 1 minus 3. So negative 1 squared is just 1. Negative 1 minus 3 is negative 4. So I have the coordinate point negative 1, negative 4. I know that this line is going down, but I don't know where, but I do know now that it's going to go through that 1, that negative 1, 4. Does everybody get what I'm doing here? Yes, no, questions? All right. I'm going to pick a number between, because I want to know when it's going to start, how far down it's going to go before it starts coming back up. So I'm at 0 here and at 3 here. So I'm going to pick f of 2. If I have f of 2, then I have 2 squared times 2 minus 3. So that's going to be 4 times negative 1, which is going to give me a negative 4. So at 2, I'm down here at negative 4. So I know it's going to come down, come back up. Now again, just like I know this is coming down, but I don't know how fast, so I'm going to go one more point after that 3 and say, okay, let me find out what's f of 4. Do we understand why I am picking these numbers, guys? Where I'm getting those numbers from? You wouldn't have to do negative 1. You just want to get on this side. So maybe you want to do negative 2. Maybe you want to do negative 3. It don't matter. You're just looking for an accurate point to run from here down. 2 is between the 2 points that I know of. So I'm finding f of 2. And f of 4 is afterwards. These are not the points you must pick. These are options that you can use. So I have 4 squared times 4 minus 3. So that's 16 times 1. So I've got 4, 2, 3, 4, and I'm going 6, 7, 8, 9, 10, 11, 12. I can't get up there, but this is going to be for 60. Okay? All right, you give a shot at your, let's see what you can do with 8. That's what I wrote. The steps that we took there at the top of y'all's page.
Did you start recording?
Yep. So, again, if I multiplied all of that out, I would have x squared plus 6x plus 9 and I'd be multiplying that by x minus 1. So when I do my leading coefficient there, my leading term, I'm going to end up with x to the third power, right? So that tells me my degree is 3, and that gives me a positive. There's my end behavior. Going up and coming down. I know that if I multiply my last, I'm going to end up with that negative 9. So that gives me my y-intercept of 0, negative 9. My x-intercept coming from x minus 1 equals 0, and x plus 3 equals 0. So my x-intercepts are going to be 1, 0, and negative 3, 0. Those are my zeros, right? My x and y intercepts are my zeros. So I have a 0 of 1 that has a multiplicity of 1. So 1 is odd, so that tells me I'm going to cross the x-axis. And then I have the negative 3 with a multiplicity of 2. And that's even. So it tells me I'm going to touch the x-axis. And because the degree is 3, I know that it's going to turn 2 times. Yes? Can we get that behavior out of our polynomial so far? All right, so I'm going to put the points on here. 0, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And those graphs that I gave you, I wish they didn't have any numbers on. You probably want to ignore the numbers on them and make your own, because some of them you're going to want to go by 5s or whatever. All right, and then I have 1, 0, and negative 3, 0. And I don't know where or quite how, but I know this has to be going up, and this has to be going down, right? I know that at this negative 3, I'm going to come up and touch that x-axis and go back down again. I know that at that 1, I'm going to be crossing, right? That's what these guys are telling me. This positive 1 with a multiplicity of 1 tells me I'm going to cross. This positive 2, or this negative 3 with a multiplicity of 2 is telling me I'm going to touch. Now I just need to plug in some numbers. And again, this is going to be kind of up to you. Now I'm not going to worry about that negative 9. Gave me that part. So I'm not going to worry about getting 1 inside. But I need to get my ends accurate. So I want to find out, right here I'm at negative 3. So I'm going to find out f of negative 4. So I can get where this line should be coming down here. Then, here, after this 1, I want to know where should this be coming up. So I'm going to find out f of 2. Just plugging them in. Negative 4, here's my original. You can plug it into the original, or if you've multiplied it. Negative 4 minus 1 times negative 4 plus 3 squared. So negative 4 minus 1 gives me a negative 5. And negative 4 plus 3 gives me a negative 1. Squared is a positive 1, so that leaves me at negative 5. So I have the point, negative 4. 1, 2, 3, 4, 5. Okay, so I know where it's going at. At 2, I'm going to have 2 minus 1 and 2 plus 3 squared. So I've got 1 times 5 squared gives me a 25. So I am not going to make that 2 25. It's going to be way up here somewhere. Unless I make all of these by like a 5 or at least a 2. Not bad. Okay? All right. One more of these. I think that's 18. That's 15. Oh no. Any questions at home?
How do you do the multiplicity part?
So you're looking at these exponents on the outside of each term. And if they're even, then you're going to touch. If they're odd, that's telling you you're going to cross. So you'll touch the x-axis at an even, you'll cross the x-axis at an odd. Does that make sense?
Like you did like 1, then the multiplicity of 1 and it crosses. How do you get like, and then the other you did negative 3. How did you get negative 3? Like in parentheses, it was a positive 3, I think.
Yeah, and then you have to set them equal to 0.
Okay. And then you use the exponents to know if it crosses the touch at the exponent.
Yeah. Mm-hmm.
Okay, thank you.
Mm-hmm. So what? Okay, so you've got 4 end behaviors, right? If it's even, your degree of your polynomial, the highest exponent you get out of it. Even, they're both going up. Okay? If it's a negative and even, they're both going down, just like any quadratic. Okay? Now, if it's odd, you have the 1 up, 1 down. Now, if that's negative and it's odd, then it's the flip, right? Your highest degree of your polynomial. Now, I've got a square and a square, so if I multiply it all out, my first term is going to be to the fourth power, right? So that's even, and it's going to be positive, so my end behavior is going to have them both up. Regardless of what happens in the middle, the end behavior is going to be both of them going up.
Mm-hmm. I know you mean the exponent is right. Why'd you do it?
So if I multiply all of this, I'm going to have x squared 2x plus 1. And I multiply all of this, I'm going to have x squared minus 4x plus 4, right? And then when I get to multiplying all of that out, my first term is going to be x to the fourth. So it's going to be even. There's 4 types of end behavior.
The y-intercept is the last number, right?
The constant. When it's all been multiplied out, because if everything else is a 0, I mean, if x is 0, all of the rest of those terms. Yes. Okay. If I multiply all of these out, my last constant term is going to be a plus 4, yes? So that gives me a y-intercept of, okay? My x-intercept, x plus 1 equals to 0, gives me negative 1. X minus 2 equals 0 gives me a 2. So far, I've got negative 1, 0, 2, 0, and 0, 4. I'm going to get rid of that, but I can't. Okay. So my zeros are just Coming straight from here, I've got -1 with a multiplicity of, so I'm going to, and I have a +2 with a multiplicity of, and I'm going to touch again. What is my max number of turning points? The degree is 4, so the degree -1, 3 turning points. It's the number of turning. That's how you find out. You take the degree, subtract 1, and that's your turning points. All right, so I know I'm coming down, and it's going to touch. So it's got to go back up, come back down, touch, and go back up, right? All right, so I'm good with this and this. I'm good with my center. I might, if I was like on a test or something, I might make sure I knew what f of 1 is. But I'm going to make sure that I know my outside, because this line I have here can't even begin to be accurate. So if this is -1, I want to find out, I want to come out a little bit farther this way, so I'm going to find out what's f of -2. And if this is 2 here, I want to come out this way, so I'm going to find out, well, what's f of 3? And then again, like I said, if I wanted to just, because this would be so easy, I could look for and find out what's f of 1. All of these points that I'm choosing, I've got options on, but I'm looking for my graph to be accurate. So I've got -2 plus 1 squared times -2 minus 2 squared. So that gives me a -1 squared is 1 times -4 squared gives me a 16. So I've got to go up to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I knew my line was going in this direction, but it is definitely not accurate. I am going from -1 -2, 16. If I did f of 3, then I've got 3 plus 1 squared and 3 minus 2 squared. That's going to give me a 1. That's going to give me a 4. 4 squared times 1 squared. I'm going to get another 16. So my 4 and 16 coming through there. Look, that eraser gets and then like I said, I can go through 1 plus 1 squared times 1 minus 2 squared is going to give me a point in here. What you think? Are these pretty easy? I know it's a lot in one problem, but every time you work one of these, go back and look at these 4 things so that, or these 5 things, so that you know where you're at. Okay? Do we remember our synthetic division? I've got to divide this polynomial by x plus 3. So I can factor out that x plus 3. If you remember your synthetic, you're not going to let me minimize you? Oh, fine. We'll just put you over here. The first thing I'm going to do is remember you're going to divide by the only way that this is x plus 3 is if this was x minus a negative 3, right? My 0 is going to be a negative 3. Whatever the opposite of this says, that's the number you're going to use. Now you're going to look at your polynomial. First thing you want to check out is your exponents. There can be no gaps. Okay? 5, 4, 3, 2, 1, 0. If this 2x to the second power wasn't in here, I would have to be putting in a 0 term. I would be saying plus 0x to the second power. Okay? You can't have any gaps. So let me put that back. And this is actually very easy. Make a list of your coefficients. 2, 5, negative 2, 2, negative 2, and 3. So just first write them all down. And again, if there was a gap, I'd be putting in some zeros here. Okay? And then I'm going to divide this by a negative 3. Step 1, after we get through setup, is bring down your first term. So that's a 2. Multiply and add. 2 times negative 3 is negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 3 is 3. Put it under my next term and add. Negative 2 plus 3 is a 1. 1 times the negative 3, negative 3. 2 and negative 3 is a negative 1. Negative 1 times negative 3, it's a positive 3, gives me a positive 1. 1 times negative 3. Now, if this is 0, then x plus 3 is a factor of this. It's like when you divide 48 by 6. Okay? So it's come out perfect. It's a 0. I have 2x to the 4th power because even though I've shortcut all this, I still factored out an x. So I'm no longer at x to the 5th. I'm at x to the 4th minus 1x to the 3rd plus 1x to the 2nd minus 1x plus 1. If this is not a 0, you're going to put whatever number you get here back over your divisor. Okay? Again, a lot looks really busy, looks like a really lot, but after a couple of times, it's pretty easy. I don't know. This is your problem. Shoot. Well, okay. So you see I got gaps, right? It doesn't go all the way, so I'm going to say 1x to the fourth plus 0x to the third plus 1x squared plus 0x plus 2. You got to fill in any gaps. 4, 3, 2, 1, and 0. So my coefficients, 1, 0, 1, 0. I'm doing binary coding. And I'm going to divide by a positive 2, right? Since that's x minus 2 equals 0 would give me a positive 2. Bring down that first term, that's a 1. 1 times 2, multiply, put your answer in, and add coming down. 2 times 2 is 4, so now I have a 5. 5 times 2 is 10, and 20. So my last term isn't a 0, so I have 1x to the third plus 2x squared plus 5x plus 10 and 22 over x minus 2 for my remainder. Yes? All right, let's try one more of those. Let's see, we did let's try 9. no gaps. I've got the 3, 2, 1, 0, right? So I'm just going to write 3, 2, -1, and +3. And I'm going to divide this by a +3 since that's x minus 3. Bringing down my 3. 3 times 3 gives me 9, 11, 33, 32, and 96, 99. So I have a remainder this time. 3x to the second power, we went down 1, plus 11x plus 32, and 99 over x minus 3.
Isn't 3 times 33 99?
Sir?
Isn't 3 times 33 99? Oh, you did 32. Okay.
32.
Okay.
Yeah. Okay? So you still have a few problems on your paper if you want to stay in practice. If you're good, you're good. Know that tonight's are kind of familiar. I did bring, there's some more of these 4 graphs over here, and then I brought some plain graph paper. If you want to take some, you're welcome to, so that you can use that while graphing. Did I get everybody signed in? Questions at home? You too. Have a good night.
Have a good night.
You too.